This is Math 6, Lesson 4-3, Prime Numbers and Prime Factorization. A factor is a whole number that divides a non-zero whole number with a remainder of 0. For example, I can say that 4 is a factor of 12 because 4 divides into 12 evenly with no remainder. A composite number is a whole number greater than 1 with more than 2 factors. For example, 12 is a composite number because the factors of 12 are 1, 2, 3, 4, 6, and 12. 12 has many factors. 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12, which makes it what we call a composite number. A prime number is a whole number with exactly 2 factors, 1 and itself. 17 is a prime number. The only 2 factors of 17 are 1 and 17. Prime factorization is writing a composite number as a product of prime numbers, which means I write a number like 12 as a product of all the prime numbers. We'll walk through that in just a moment or two. There are many ways to find factors. One of the ways to find factors is understanding that you can list the factors of a number. You have to be able to list factors of numbers so that you know all the ways in which a number can be divided. For example, the number 24. If I wanted to list all the factors of 24, the first thing I would do is think of all the ways that I could divide 24 up. And I'm very systematic. I like to think logically, what times what equals 24? And I start with the smallest number and I go to the biggest number. For example, I go, well, I know 24 is 1 times 24. Next number higher than 1 is 2. Does 2 divide into 24? Yes, it does, 12 times. Does 3 divide into 24? Yes, it does. 3 times 8 is 24. Does 4 divide into 24? Yes, 4 times 6 is 24. Once you realize, see how these numbers are fairly close together? The only number between them is 5. I know I've gotten all my factors of 24. Now to list my factors, I need to go down this side and then back up this side. For example, my factors of 24 are 1, 2, 3, 4. That's going down the left-hand side. Now I'm going to go up the right-hand side. 6, 8, 12, and 24. This way they stay in order and they're easy to keep track of. So I divided it out and then I wrote my factors in order going down the left-hand side and up the right-hand side. If you are systematic, it makes it much easier to not miss a factor. Let's look at 35. So 35, I think to myself, well, I know 1 times 35 is equal to 35. 35 is not divisible by 2. 5 plus 8 is 3, so 35 is not divisible by 3. It's not divisible by 4. It is divisible by 5. 5 times 7 is 35. There's only one number between 5 and 7, and that's 6, and 6 does not divide into 35. So I have found all the factors of 35 now. My factors of 35 are 1, 5, 7, and 35. Being able to take a number and list all its factors is important because it will help you simplify fractions, it will help you find common denominators, it will help you divide problems out, and later on in much higher level math classes, it will help you with much more difficult problems. Let's take a look at an application problem. A gift box must hold the same number of pairs in each row. You have 24 pairs. What arrangements can you make? In other words, I have a box. Because the box wants to look appealing, you don't want to have, oh, let's do 3 pairs here, and let's squish 5 pairs in here. No, that's not a good thing to do. They want it to look appealing. They don't want it to be hodgepodge, throw the pairs into the box. So I'm going to throw this pair into this box. I can't draw pairs, can you tell? Okay, here's my little pair. Okay, we don't want to do that. So what they want is they want a box that's got the same number of pairs in each row. Okay, so they're like, we would like it to be beautiful. You know, we want the same number of pairs in each row so that when someone opens it up, they go, oh, how lovely my box is. Okay, look at all these beautiful pairs. So we need to figure out what types of arrangements can we make. So I'm going to look at this and say, oh, 24. What ways can I get 24? Well, I could have a box that has one row of 24 pairs in it. That would be a very long box. Now, you might like it. It might be kind of cool to get this really, really long 4-foot box delivered to your house. Okay? I could have 2 rows of 12 pairs. I could have 3 rows of 8 pairs. I could have 4 rows of 6 pairs. Okay? Which means I could also have 6 rows of 4 pairs, 8 rows of 3 pairs, 12 rows of 2 pairs, and 24 rows of 1 pair, which would be the same thing. Okay? It's just the difference between these is which direction the rectangle is. For example, do I have 1 row with 24 pairs this way? This would be 1 by 24. Or do I have 1 by 24 this way? It's still the same thing. If you rotated the box, it would be still the same number of pairs in the box with the same arrangements. So our arrangements could be 1 row of 24, 2 rows of 12, 3 rows of 6, or 4 rows of 8. Okay? So we should write that. We could arrange it. That is in 1 row of 12, excuse me, 1 row of 24, 2 rows of 12, 2 rows of 12, 3 rows of 8, 4 rows of 6. Okay, I should write that properly in English. 1 row of 24, 2 rows of 12, 3 rows of 8, or 4 rows of 6. Okay. Since it was a word problem, we need to write the answer in a complete sentence. And this all follows just us factoring how many different ways can we arrange 24. Prime or composite? How do you tell whether a number is prime or composite? Well, you have to look at it. If you know your prime numbers, you'll be great. Most people don't know their prime numbers. Okay? We'll talk in class a little bit about how you can figure out your prime numbers a little bit easier. So I'm looking at this. 61, is this prime or composite? Well, I think about it. Is it divisible by 2? No. 3. 6 plus 1 is 7. No. 5? No. 6? No. 9? No. 10? Do I know of any number that multiplies together or divides into 61 with no remainder? I don't, because I know that 61 is prime. Okay, so I know that this is a prime number because, and I can explain it by saying it only has 2 factors. One and 61. 65, is that prime or composite? I look at that and go, it ends in a 5, so it's divisible by 5, so that it has to be composite. How do I know it's composite? It's divisible by 5. Which means it has more than 2 factors. If it's divisible by 5, 5 is a factor, 13 is a factor, 1 is a factor, and 65 is a factor. Therefore, it has to be composite. One very important thing that we learn when you get into higher level math classes is something called prime factorization. Prime factorization is being able to take a number and break it down so that it is the product or the multiplication of all of its prime factors. There are 2 ways to do it: division and a factor tree. I will introduce both methods. I will ask you to practice both methods. After you've practiced both methods, you can choose whichever method is easier for you to remember how to do and that you're more successful with. But you won't know that until you've practiced both methods to decide which one you like better. The one method is division, and it's kind of like upside down division. I've always explained it as upside down division because you're basically dividing opposite of what you normally have. For example, when you do this, you want to when you're going to do division, you kind of want to find the smallest prime number that'll divide into your number. I mean, you can find any number, but it's a whole lot easier to find the smallest prime number. I know that 84 is divisible by 2. Notice how my division is now going upside down. 2 goes into 8 4 times, 2 goes into 4 twice. Ah, that's divisible by 2 as well. 2 goes into 4 twice, 2 goes into 1, 2 once. Okay, and you're like, well, 2 doesn't divide into 21 anymore. Oh, but 3 does. So I can take this and go, oh, 3 goes into 21 7 times. 2 is prime, 3 is prime, 7 is prime. So I have now broken it down to all of my prime numbers. Okay, all of my prime numbers. And I've seen this division go this way. I've also seen this division go this way. I've seen people who do it this way. And you go 42 this way, and then you do 21, and then you do 7 this way. So I don't care if you do it upside down or right side up. I always learned it upside down, so I go down. But you can do it up. It doesn't bother me, just as long as you keep dividing. It's successive division is what it is. So if I was going to list the prime factorization, the important thing about listing prime factorization is prime factorization must be listed from smallest to largest. And what do I mean by that? That means this. Okay, this, if I looked at this, I have 2 times 2 times 3 times 7. So 2 times 2 times 3 times 7. That's the prime factorization. The smallest number is 2, the largest number is 7, and the 3 is in between those. We could write this number using exponents as well. I have 2 2's, so that's 2 to the second times 3 times 7. So it can be written either way, okay, with with exponents and without exponents. This one is with exponents, and this one is without exponents. Pay attention. Sometimes the book will ask you to do it with exponents, and sometimes the book will not say, and if it doesn't say, you can choose. So the prime factorization of 84 is 2 times 2 times 3 times 7, or 2 to the second times 3 times 7. Now you might say, well, that's one method, that's the division method. What's the factor tree method? Well, the factor tree method, it's called a factor tree because it branches out. It looks like branches of a tree. You choose any 2 numbers that you know will multiply together to get 84. Okay? Any 2 that I want. I already know that 2 times 42, so I might say 2 times 42. 2 is prime, so I'm going to circle it. I circle all my prime numbers so I don't get lost later on. Now I take any 2 numbers that multiply together to get 42. You might go, oh, 6 times 7. Perfect, 6 times 7. 6 is not prime, 7 is, so I circle it. I circle my prime numbers. Okay, 6 is not prime. 6 is 2 times 3. Both of those are prime, so I circle them. I have no numbers left that I didn't branch off of that are not prime. Okay, 42 I branched off of, so I don't have to worry about that. 6 I branched off of, so I don't have to worry about that number. So the numbers that I circled are my prime factorization. So my prime factorization is 2 times 2 times 3 times 7. There has to be a multiplication symbol between your numbers because prime factorization is multiplication. It's what are the prime numbers you have to multiply together to get to this bigger number that we just divided out. So you have to show those multiplication symbols. These are important. They have to be there. Okay? Or we could write it in exponential form, 2 to the second times 3 times 7. We should have gotten the same answer as we did before, and we did, which is good. 2 different methods. Once you've practiced both methods, figure out which method you like best and stick with it. So let's practice some. Let's find the prime factorization of a couple of numbers. And we'll do one by the division method and one by factor tree. Let's do the division method for 27. So 27. What divides into 27? Well, I know 3 divides into 27. 3 divides into 27 9 times. What divides into 9? Oh, I know 3 divides into 9. 3 goes into 9 3 times. So the prime factorization then of 27 is 3 times 3 times 3, or 3 to the 3rd power. And we use division to find that. And I actually did it going up rather than going down because most people prefer it going up. Prime factorization of 90. I'm going to use the factor tree for this one, just because I think factor tree is a little harder for people to follow at the beginning. Okay, 90. I know that 9 times 10 is 90. Neither one of those are prime, so I'm not going to circle either one of them. 9 is 3 times 3. Both of those are prime, so I will circle them. 10 is 2 times 5. Both of those are prime, so I will circle them. I now have 90 broken down so that all the branches are only prime numbers. Once I've done that, I just need to list it in smallest to largest. So I have 1, 2, I have 2 3s, and I have a 5. So 90 is 2 times 3 times 3 times 5, which it is, because think about this. 2 times 3 times 3 times 5. Okay? 2 times 3 is 6, 3 times 5 is 15, 15 times 6 is 90, or 3 times 3 is 9, 2 times 5 is 10, 9 times 10 is 90. We know that this is 90, so 2 times 3 squared times 5 would be the other way of writing it. You have to write it in smallest to largest. You can't write 3 times 3 times 2 times 5. You can't write it in the order that you've finished it. You have to write it in smallest to largest order. That's prime factorization.